This video will discuss abstraction. Let's consider some classes that might represent a university. We will have a person class, and then it will have two subclasses, instructor and students. And you can see that there's other forms of UML in this diagram, including aggregation. This is a good example of aggregation, but that's not the point of this lecture. So we have the superclass person. It has a name. Persons can register for seminars. And the instructors have office hours and a getter for those office hours. And the student has a year of study. They have freshman, sophomore, junior, senior, and they have an option to withdraw from a course. Great. Now, in the past, these would all be concrete classes. And what's a concrete class? A concrete class is a class that you can make an instance of. But let's face it, we don't really want to make persons because a person is too generic. It doesn't mean anything. Rather, we would want to make instructors and students. So one way we can do all this is to make person an abstract class. An abstract class can't be instantiated, but it can still act as a superclass. Other classes can derive from it, like instructor and students. And the abstract class really represents the most generic form of the type of object that it is. And how do we make an abstract class? It's really easy. All we have to do in our class definition is just add the word abstract. When we do this, we will convert person from a concrete class to an abstract class. Now, in UML terms, the person, if it's italicized, that means it's an abstract class. It's a little subtle, but you can see that perhaps in the UML diagrams to follow. Again, when we make an abstract class, we're really just taking the concept of a person and putting it in a superclass that we will never want to create. And that superclass can certainly have concrete methods. Even though we're not going to instantiate an instance of that superclass, it would be great to have some concrete methods that the subclasses could inherit. But here's something else we can do in an abstract class. An abstract class can have abstract methods. Abstract methods are methods that appear in the superclass, but they expect to be overridden. In other words, what we're saying is that if you want to be a legitimate subclass of this superclass, you must implement certain minimum behaviors. You must implement the methods that are abstract. So an abstract method has only a header and it has no body. So there's no code in the abstract method. Now, if you have a method that has no code, it obviously can do nothing when you run the program. So what we expect then is that we expect the subclasses to override the method. And if the subclass does not override an abstract method, we're going to get a compiler error. Because at some point, the abstract method has to have a body. It could be in the subclass, it could be in a sub-subclass or a sub-sub-subclass, but at some point, the implementation has to be provided. Now, if you have an abstract method in your class, it is automatically abstract. What does this mean? This means that the class cannot be instantiated because basically some of the code is missing. The abstract method doesn't have a body. And like we said before, the abstract method is a way to ensure that the subclass implements the method or follows the behavior. So let's think about this. At a university, we have many kinds of persons, and we can make an instructor and a student as we've done. And we might want to say that all students have the ability to vote. Maybe they could vote for a speaker to come on campus. But we would like to ensure that as this application grows and expands, that all persons at the university have the ability to vote, even if we haven't subclassed them yet. So there are people besides students and instructors. We have registrars, we have deans, we have secretaries, and all of these people would have the ability to vote for certain topics at the university. To guarantee that all of those subclasses will eventually have an implementation of voting, we could make vote an abstract method of the person class. Then we know that in order to be a legitimate person, you have to encode in the method the way a person would vote. Now, obviously, if everyone voted the same way, we would just make this a concrete method. The idea of making an abstract method is that maybe the students' votes count more. Maybe instructors' votes count a little bit less. Maybe the administration staff, their votes don't count much at all, but a little bit. So this way we can have different behaviors for vote, but we will ensure that every single subclass has a way to vote because we made it an abstract method of the superclass. Here we have another example of this. This is our person class, our abstract class, and before we had a method called register for seminar, and we have now made that method abstract. Again, you can tell it's abstract because in UML it is italicized. To make it abstract, we say that it has no body, and the body has to be implemented in the two subclasses. Note that this method now appears in the UML for the students, and it also appears in the UML for the instructor. And because we made it an abstract class, we can assume that the implementations of these methods will be different for each of the two subclasses. And in fact, that's true. For the student subclass, we make sure that the student gets permission from the faculty to register for the seminar. But for the instructor class, we just let the instructors register without any permission being sought. So again, two different kinds of behavior, but each of these subclasses had to implement the register for seminar method because it was an abstract method in the superclass with no body. Like the vote method we discussed before, there are two possible techniques for the method register for seminar. We could make it abstract in the superclass and then force each subclass, all the current ones and all the future ones, to implement the body of the method. Or we could make register for seminar concrete in the superclass and then allow the subclasses to override it if they didn't like that behavior. So now we know that a concrete class can have concrete methods. In fact, all the methods of a concrete class must be concrete, and an abstract class can have either concrete methods or abstract methods. Okay, let's switch gears and talk about a concept called multiple inheritance. Multiple inheritance is the ability of a subclass to inherit instance variables and methods from more than one parent. Here we see we have a catalog, and the catalog will have an array list of courses, but the catalog wants to inherit from two different kinds of superclasses. The first is an advising document. And we'll say that a catalog is a advising document, and it would have a level. Is the level undergraduate? Is the level a graduate catalog? So we'll store that variable. And then an advising document will have a method called acknowledge. And this would acknowledge that the students, in fact, have read the advising document. Sounds good. But a catalog might also be considered a smart document. What's a smart document? A smart document is a document we can talk to and ask it questions, and the document will answer back. Sounds like fun. The smart document is going to have an instance variable for the language, English, French, German. And the smart document will also have the ability to have some methods, including asking a question of the documents, and you can pass it a voice command, and hopefully the smart document will answer you nicely. So what we see here is a situation where the catalog really wants to inherit from two different kinds of superclasses. However, this is not allowed in Java. So we have to think of another way to simulate multiple inheritance. So at the top of this slide, we see what we saw in the previous slide, where you have a class trying to inherit from two different superclasses, but that's not possible. What is possible, though, is for our class catalog to inherit from one superclass, that is the advising document. And that makes sense because a catalog can be classified as an advising document. So this way it will inherit the level and it will inherit the method acknowledge. However, a catalog is also a smart document, and what we can do is we can have this class catalog implement an interface. And when you implement an interface, you have the ability to pick up certain things from that interface. In this case, you can pick up the method ask question, which is nice. As you can see, we could also pick up other things from an interface, such as static constants, but sadly, we cannot pick up instance variables from an interface. So that means that the instance variable that we used to see, called language, which you can see up here, we have to actually move it down into the subclass. So not terrible, but now we can say that the catalog extends the advising document and implements the smart document. And we'll see how this works coming up. Before we start to look at the code for an interface, you should be thinking to yourselves that an interface reminds you of something. The interfaces should, in fact, remind you of abstract classes. And indeed, an interface is very similar, though different, from an abstract class. Like an abstract class, an interface cannot be instantiated. I cannot make an instance of a smart document, just like I could not make an instance of an abstract class. Secondly, the purpose of an interface is to specify behavior of other classes. An abstract class can have an abstract method or a concrete method that can specify behavior of its subclasses. Similarly, an interface can also specify behavior for other classes. We will, however, not call them subclasses. We will call those other classes classes which implement the interface. And as we said in the previous slide, interfaces are used by Java to simulate multiple inheritance, which, as we know, is impossible in the Java language. Okay, so let's look at the couple of ways we can do this. And the first way is we can have a default method. A default method is going to have a body. And in this case, we have the default method askQuestion, and we describe exactly how we want this method to work. And this default code could be picked up by any class that implements this interface. The other option we have is to do the same thing we did in the abstract class, and that is to have an abstract method. And the abstract method will again have the keyword abstract, and it will end in a semicolon, and there will be no body to the method. So again, what are our two choices? Our two choices are a default method or an abstract method. Okay, last slide, but an important one. This will highlight the differences between an interface and an abstract class. So an abstract class, as we know, can contain abstract methods or concrete methods. And the interface can contain abstract methods and default methods. The interface needs that keyword default to really give you a concrete implementation. The abstract class is certainly capable of having some static constants that apply to the entire class. And the interface can also have static constants. And again, neither the abstract class nor the interface can be instantiated. On the abstract class side, we know that a class cannot inherit from more than one superclass. It can only have one abstract class parent. However, on the interface side, you can implement as many interfaces as you like. So a class could extend to class A and implement classes B, C, D, E, and F. No limit. The abstract class can contain static methods that work at the class level. The interface can also have static methods that can have a body as well. In the abstract class, methods can contain code as well as being abstract. In the interface, your non-static methods may have a default body, and any object that implements an interface is marked as that interface type. Now, what this refers to, this latter part, is instance of. See, if you extend a superclass or you implement an interface, whatever class does that is a abstract class and basically also is an instance of the interface. So the instance of operation can show you whether you are extending a class or implementing an interface, and that's going to come in very handy. And that, in a nutshell, is abstraction. I hope you learned a lot from this lesson and enjoyed it. See you next time.